All right, guys, so for this walkthrough, we are going to be designing a finite state machine. Now, we've talked up to this point about designing a state machine for all of the different types of states that we could possibly have. I'm going to walk through kind of designing a couple very simple states, and then as we're doing it in class, we'll be adding more to it. But we need to build up the entire process. So to start off, we need to design a state. So we're going to go to Create File, and we're just going to call this states.js. Okay. Now, for this as a class, we're going to use this as a model for all states. And the way that this works is that every state is going to have the same functions. So we'll run state, dive state, duck state, fall state, hurt state, all of those are going to have the same type of functions, and we're calling them in a very prescribed order. So because we're doing that, then we can leave the managing of when we transition to each state based on our rules that we are setting. So if we are jumping, then as soon as we hit the ground again, then we can transition back to a run state. If we've run off of a platform, we can transition to a fall state. Easy, 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 okay? So we got to design this. So we're going to start off with state, okay? And with this, we have to have our constructor. Our constructor is going to have two pieces of information to start. We're going to have to know who the subject is that owns that state, and if it is poppable or removable is the word that we could use. So if it is poppable, then the way that we're doing it is that we could remove it and go to the previous state that it was in. We need to hold that kind of information so that, say we were jumping, then we threw an attack, we got hit by an enemy, we need to register that we're hit, show that we're in the hit state, but then be able to go back to our jump state from wherever we were. So we need to be able to hold that information. So that's why we need that poppable. Okay, so in here, you're just going to say this dot subject is subject. This dot poppable is the poppable. Okay, now we may make some changes to these as we move forward depending on our need. Okay, now whenever we transition to a state, we always go into an enter function. So on here, I'm just going to write some text on here so that we can see it when we're in our default if we have not overwrote it. Okay, so this is the default enter. Okay. That should only happen once. When I transition from one state to a new state, I should be calling this enter function. This is where I can change values that I need for whatever current state I'm going into. And then I am going to end up having an exit state. And this is where I'm transitioning those values back to something that it previously was. Anything that I have to reset that I don't want to affect any previous states. There may be stuff in here, there may not be stuff in here, depending on what state we have. So this is the default exit state. Okay, and then every state is going to have a handle input function. Okay, and this is going to be used for getting any type of controls. Now, if we are using the player, this would be keyboard commands, gamepad commands, touch commands, anything to move the player. We're updating that stuff, okay, with here. We're looking for those triggers, and then we're dealing with it. If this is if we were building a state for an enemy, then these might be the AI components that we're using to determine what to do. So this may be the enemy is within a certain distance of the player, so it might, change its aggression level or something like that. Okay, so let's write another console.log. This is the default input state and then we need an update. And an update is going to take our handle input, any changes that we made for that, and then update our player. So this would be like updating our player's position, changing animations, anything that we need for what needs to currently happen while we are in this current state. Okay, so let's write another one, console.log. This is the default update state. Okay, so that is my base state. Every state is going to be using these functions. We have to use, at least have a subject and whether it's poppable. Probably helps if I spell poppable right. Okay, so we have a state. Now we need to design a FSM. So we'll just call it fsm.js. And in this, we're going to have several components in here that we will use to design jumping from state to state, okay? So this is where kind of the magic happens on what we need. So we have to have this working up correctly, and then we can design states as we need. So let's write a constructor. Constructor, we don't really need anything in there, but we are going to have a stack. Okay, and this is just going to be an array for here, but really what we want is, think of it like an inbox for like your mail. Okay, we are seeing stuff, so as we get things, or if I was taking dishes out of a dishwasher and I'm putting them in the cupboard, as I take them out, I'm putting these dishes and I'm stacking them on top of each other. Okay, the first state we're on is going to be the one that's on the very bottom, and this is our stack. So if we add a new state, we go into a jump state from a run state, then that is getting added on top of the run state. I should be able to transition back to that run state if I'm transitioning from that previous state. So I'm pulling off that top dish and I'm looking at the dish below. So that's what that stack is going to be doing. It's going to be holding that stuff for us. Okay, we need to have a current state. We'll set it to null to start off, and we're going to have a next state, and we'll set this one to null. Okay, and null is just because we don't want to set a value here. We're going to pass in something. And what we're really doing is we want to know what our current state is. We're going to set that. And then whenever our current state is going to change, as it changes, it's going to automatically change in here based off of our criteria that we're setting. And then we're actively looking for the new state that we need to transition to. Okay, so the first thing that we need to do is we should identify whenever we need to check what the current state is. That should be a function. So I'm going to quickly return that. So in this, I want to ask a question. I'm going to say if this.stack.length, if that's greater than 0, then I want to return that the last one on the stack. Okay, so I'm going to do return this.stack, and I want it as the last one, excuse me, so like this. I want to return the last one in the stack, which would be this.stack.length minus 1. Okay, that would be the last one that's been added. If I don't have one, I'm just going to return null. So else return null. Okay, so this is going to get called whenever we're trying to find out what the current state is, to make sure that we're always returning the last one. And then with that, we can start building some of our other pieces. So let's do a couple easy ones. We want a pop state. So what this function does is that if I can remove a state, remove that dish from the stack of dishes, from there, I want to be able to remove it. So in this, I'm just going to say this.stack.pop. And that's all that I got to do. Okay, what that's doing is that is removing the pop state. Now, this by default will return it, and I could do something with it. In this case, I don't really need it. I'm done with that state. I want to go to the one below it. So all I need to do is just pull that last one off the stack. Okay, let's do the next one. We're going to do a push state. So this is the opposite. We want to add a state. Now this one is going to need to have quite a bit of error checking. Okay, we need to check if the state that we want to add, so we're going to pass in a state, if the state that we want to add is not null. Okay, and so like here, if that state, then when we're doing the get current state, if that was called here, if that was null, I don't want to do anything with it. If I passed in something that doesn't exist, I don't want to do anything with it. If the state also is not the current state, okay? So this is where I would want to ask that get current state. So I'm going to actually call this function, make sure that the state that we currently have is not the same one. So this dot get current state, okay, is not equal to the state that I'm wanting to add. Okay, if both of those are true, then I need to ask if the state that I currently am on is, well, the current state that I have, I should exit it. I start the exit sequence, and then I need to see if I need to remove that one from the stack, or if I'm adding a new state on top of it. Okay, so this one, let's call this dot current state. That's this state right here. Okay, which should be set when we're doing this. The current state, I want to call the exit method on it, whatever it is. Okay, now this current state that I'm on, if this dot current state is poppable, so poppable, if that's true, then I need to pop it. So that's using this method right here. This dot pop state. Okay. Now I need to check my current state. I want to make sure, so now I'm looking at the state right below. I need to double check that it's not the same thing in here. So the state that I want to pass, if that's run and I just removed, say, the jump state to a run state, then I want to check to make sure that that is not also a poppable state. So let's go to that. We're going to ask another question. We're going to say, hey, if this dot get current state dot, and let's do constructor. If the constructor, now this is a function, if the constructor is the same, is not the same as the state that I'm passing in that constructor, then they should be completely different. Okay, and that's kind of going off of a memory space, but basically we want to make sure that what we are trying to add on is not already on there. If that's true, then I want to push that state. So this dot push, this dot stack dot push, and push that state. I got to double check if that has to be with parentheses or not. Yeah, so that's good. Okay. So after we check that, so ideally when we are pushing a state, we're making sure that that state actually is a state. It's not the state that we are currently on. If both of those are true, then we are executing whatever exit code that we need for the current state. We're checking if that state that we're currently on is poppable. If it is, we remove it from that stack. Now we check the state right below that one that we just removed, make sure that they are not the same as the state that I'm wanting to add. If that is true, then I'm adding this new state. If not, then my current state became, because I removed this, my current state is now my, so this I'd say my current state is now this dot get current state, and that would tell me that the last one on my stack, that's what it is. Okay, and then I can call the enter on this. Now I may end up playing around with this a little bit on where we're doing our enter, current state dot enter. Okay, so see how we're calling our exit and we're calling the enter. We don't really care what state it is. It could be a duck state, dive state, hurt state, dying state, dead state, any one of those. We're calling the exit first, removing that from the list. If we can add another one, we are adding it. Otherwise, the one right below it becomes our new state, and then we're calling the enter on it. Okay, that's when we try to push a new state on. Okay, so that's quite a bit that we had to do just to make sure. Last function that we need, actually we need two more. We need an update. Okay, now this update is going to be, for a finite state machine, it is going to call whatever state we're currently in. It's going to call that handle input. If that handle input returns a new state, then that becomes our next state that we need to transition to. And then we need to also do our update. If the update returns a new state that we need to transition to, then we're going to have to do that. So on here, we're going to do this dot next state. And I'm going to say E is this dot current state dot handle input. So remember, that will return a state if there is one. Okay, if it is, then I'm doing that push state. So I'm going to say this dot push state, and I'm going to return this next state. Now that may be null. If it's null, I don't care. If it is not null and it's a new state, then I'm going to deal with it here. That's why we designed it this way. Okay, the next thing I need to do, this dot next state, is going to be this dot current state dot update. Okay, so same thing. If there is anything in there, if we did transition a new state, then we're going to add that to our new state. Repeat over and over and over ad nauseum for our character. Okay, the last thing that we really need to do is set an initial state for our FSM to run. Okay, this should be some default state that we can pass in whenever we want to do it, where we're going to set this current state and run it. Okay, because right now our stack has nothing in it. We need to put something in it to start off the entire process. Okay, so we'll create one more function. We'll call it set initial state. We're going to have to pass in a state. Okay. If I have to redo it like I'm starting a game over, I'm going to treat this kind of like a reset. So if my player or my enemy, I need to start the game or reset or transition to a new level, I'm going to set the stack back to an empty array. So I'm just getting rid of any previous states. Okay. This dot push state. Okay, so that's calling this method to make sure. Again, we have to make sure that we don't have a null state. Okay. Stack push state. This dot current state is this.get current state. I want to make sure that it's not the same one that may already be on there. I'm just doing some error checking. Okay, and then in this, I need to, by default, call the enter function on that to start it running. So the very first time we run our FSM, finite state machine, we're calling the enter, and then we're getting into the update. Oops, we might not want to push the state here because there is nothing here. We don't want to call the update there because we're just going to push it directly onto the stack. Stack.push state. We just need to make sure that we're pushing on a good state. Okay, so this will be fine then. We're calling the enter, and then we'll come to the update. We will update as needed, okay? The FSM is only responsible for managing all the individual states, and then I just have to design what states my player will have, okay? This is the main components that we need to have in our stuff. As we develop the player, we're going to be creating new state that they are in, and then using that to dictate when we transition for abilities, moves, and for animations. All right. Make sure you have the FSM completely created with all the functions that I stated, and you have the base class for the state that has all of this information in there. Good luck. Have fun.